Problem number 4. Several identical cars are standing at a red light on a one-lane road, one behind the other, with a negligible and equal distance between adjacent cars. When the green light comes up, the first car takes off to the right with a constant acceleration. The driver in the second car reacts and does the same 0.2 seconds later. The third driver starts moving 0.2 seconds after the second one, and so on. All cars accelerate until they reach the speed limit of 45 km per hour, after which they move to the right at a constant speed. Consider the following patterns of cars. Just before the first car starts accelerating to the right, the car pattern will qualitatively look like the pattern in the first row. After that, the pattern will qualitatively evolve according to next rows. Solution. Let's check the first and second cars. When the first car starts, it starts to increase distance between first car and second car, and this distance will increase till speed difference is increasing between cars, and this increase will stop only when second car stops to accelerate and reach the speed 45 km per hour. So it means that during all this acceleration time, each car which is ahead another car, the distance will increase, and distance will stop to increase when next car stops to accelerate and reach the highest speed, 45 km per hour. From this point we can analyze all rows, and we see that row 2 is good because it's always distance increasing between cars. Third row it's not good because distance will decrease between first and second car, and between second and third car. And row 4 is good because this is final position when all cars moving with a constant speed. So it means that first, second and number 4 rows are good, which is answer B. This was the solution for problem number 4. Problem number 5. A projectile is launched with a speed v0 off the edge of a cliff of height h at an angle theta from the horizontal. Air friction is negligible. To maximize the horizontal range of the projectile, theta should satisfy next inequalities. Solution. First, let's draw the picture. Suppose on this trajectory we have a picture where green trajectory is the path of projectile which has initial angle greater than 45 degrees. That's a phi angle. And blue trajectory is a path for projectile with the initial angle psi less than 45 degrees, and that's equal to 90 degrees minus phi. In that case, they will cross point B, which is on the same height as point A, in the same point. And the red path, that's some kind of path for projectile which is going with the speed with the initial angle 45 degrees. Of course, this is just a divider for these two trajectories. Now let's write what happened to velocities of these two cases. For the green trajectory we have Vx1 equal V0 cosine phi, and Vy1 equal V0 multiplied by sine phi. And the same thing for blue trajectory. We have Vx2 equal V0 cosine psi, and Vy2 equals V0 sine psi. And because of this relation, one of angles greater than other, angle, we can write an equations. We have Vx2 greater than Vx1, and we have Vy2 less than Vy1. And in point B they have the same values, but except that Vy will be down, not up. What does it mean? It means that for green trajectory we have vertical speed is greater than for blue trajectory. It means that to cover this height, green projectile will spend less time than blue object. But speed of blue object greater than speed of green object in horizontal way. It means that total path which will cover blue object in horizontal way will be larger than path of green projectile, and that will happen in any case when we have this relation. So finally we have distance covered by blue object Vx2 multiplied by t2 greater than distance covered by green object, which is Vx1 multiplied by t1. And this is the solution for problem 5, and the correct answer is C.